Scottish Government's Dynamic Coast project provides the evidence base on coastal changes across Scotland. The project aims to improve the decision-making across the public sector and support communities and businesses and infrastructure managers in their awareness of the impacts of climate change on our coast. The project was commissioned to support public sector duties within the 2009 Climate Change Act and aspects within the Scottish Climate Change Adaptation Programme, alongside the work that's required within marine and terrestrial planning. The project was funded by CREW, Scotland's Centre for Expertise in Waters, Nature Scot and the St Andrews Links Trust. DynamicCoast.com has the initial research results from 2017, and these will be updated in May with the latest findings. The 2017 research found an increasing extent and rate of erosion affecting our erodible shores. With climate change, we expect erosion and erosion-enhanced flooding to affect more shores, more coastal assets, and more communities into the future. We need to start planning now. Let's be sea level wise. Over the next few minutes, you'll hear from the rest of the team on our latest work.
In this new phase of Dynamic Coast, we're making huge improvements to the evidence base, which should help you make better resilience and adaptational decisions. We have a host of new datasets covering the recent and more distant past to fill any knowledge gaps about our coast. We have updated and improved our methods from the first phase of Dynamic Coast to draw even more value out of our geospatial coastal data. And we've introduced some entirely new methods, which focus on more localized analyses in 3D as well as 2D, and apply novel remote sensing technology to the coast. The data improvements made to this round of analysis include the latest tidal updates from Ordnance Survey. Since 2016, over 2,200 kilometres of shoreline have been updated. Working with the OS, we have also investigated and improved our understanding of the survey dates of these shorelines to pinpoint real-world shoreline movement. We have included the latest Scottish Government LiDAR phases in both the expansion of our mean high water spring positions database and in our elevation change analyses. We have also benefited from updates from our project partners. For example, vegetation edge surveys from Montrose Golf Links, which add greater complexity to the history of a particular coast's change, as well as aerial and ground-based laser scans of elevation surfaces, as seen here at Skara Brae from Historic Environment Scotland. We have also improved our methods with new approaches to measure real-world change between these different datasets. Not only do we have a sense of past 2D change through more mean high water spring positions, but we can now perform detailed three-dimensional appraisals of sediment and vegetation dynamics to infer how sediment movement has created those 2D changes, and how flooding and storms may interact with those surfaces in the future. Our natural flood barrier extraction tool automatically picks out the key dune formations currently protecting back dunes from flooding and quantifies how erosion may impact these barriers in the future. Additionally, we have improved the modelling of future shoreline change to take account of anticipated sea level rise with the changing climate based on the UK's 2018 climate projections. We also have an entirely new set of methods which are revolutionising the way we record and analyse changes across the intertidal zone. Our Coast X-ray tool uses the European Space Agency's Sentinel-2 satellite imagery back catalogue to appreciate the extent of our intertidal area. By building up a time series stack of satellite images across the entire UK coast, taken at different tide heights, we can identify down to a 10-metre resolution where along a coastal edge is always wet, where is always dry, as well as a percentage of water occurrence in between. This water occurrence layer gives so much more information about the recent coastal change than snapshot images or coastal surveys taken at only one instant in time. Matching this with known tidal elevations then gives a pseudo-digital elevation model, allowing for constantly updating comparisons with published shorelines. I will now hand you over to Martin, who will explain some of the analytical methods we have applied to this new phase of work.
Using these improved data, we've been working to identify and map natural coastal flood defences along Scotland's coastline and assess the potential for them to be eroded in the future. Natural coastal flood defences are topographic features such as barriers or dune systems near to the coast that afford protection from elevated coastal waters to some low-lying terrain further inland. For example, the photograph here shows a barrier on the coast of Montrose that is being affected by ongoing erosion. As natural geomorphic features, these landforms are changing through time. Their protective function may be being impacted by erosion now and into the future, which could enhance flood risk. So understanding and working with these natural assets that are already present on our coastlines can provide a buffer between us and the sea when planning to mitigate coastal flood risk. Our approach scans the Scottish coastline topography to identify all such features. Extracting cross-sections perpendicular to the coastline, like the one you can see here in red, we develop routines to delineate these barrier features that are protecting lower-lying topography inland. Once identified, we can measure their geometry, such as the width, their elevations, slopes, and determine the volume of material that's contained within them relative to estimates of extreme water level. These sorts of metrics give a sense of how effective these features are as natural flood defences and can provide us with a basis for targeting the most vulnerable areas of natural protection. But given predictions for future erosion, we can also identify locations where erosion may result in enhanced flood risk in the future. Predicting future erosion along Scotland's soft coasts is a larger goal of the project. We're taking an approach that builds on our previous work that measured past coastal change, but taking into account expected acceleration in the rate of sea level rise around all of the Scottish coast. The method used factors in the effect of nearshore bathymetry and the inland topography where appropriate, so that, relatively speaking, steeper coasts are less vulnerable to erosion compared to gentle, low-lying coasts which are more erosion-prone. The model's trained on recent observed coastal change, and these observations have been updated based on new data that has been collected during the project. So the effects of sea level rise are imposed onto how we have already seen our coasts to be evolving. Our predictions take into account the proximity to bedrock and the presence of any engineered coastal defences, ensuring that predictions of coastal change and of erosion stop when they encounter materials that aren't easily erodable. As users, you'll be able to see on our web map the predicted future shoreline positions every decade to 2100, and will have mapped areas at risk of erosion expected by 2050 and 2100. You'll be able to explore deeper by clicking on individual transects and focusing on specific sites, and make comparisons between our previous results and the updated predictions that are factoring in the effects of accelerated sea level rise that are generally resulting in us predicting more rapid shoreline erosion. Some areas that had previously not been observed to be eroding may begin to experience erosion in the coming decades. And these predictions will help us to establish who and what are most at risk.
Hello everyone, I'm Professor Larissa Naylor and I'm following on from Martin Hurst, who was just talking to you about the challenges of erosion and the findings of Dynamic Coast 2. And I'm coming along to talk about what we've done in terms of using the Dynamic Coast results to develop dynamic adaptation and resilience plans. So what you'll have seen from the earlier slides is that climate change means we have to reframe our relationship with the coast. It's a dynamic zone and it's not a fixed line. And so if you can see from these images, this is an art exhibition from the north of Scotland that went viral globally about visualizing what sea level rise may mean for this particular croft. And on the right, you have current state of defences in the city of Edinburgh. And below, you have an example of erosion of the car park for a ferry terminus on the Aran Islands in Ireland. But what they all illustrate is that the coast is dynamic, it's not fixed. And so natural capital that we've talked about earlier in the slides, such as beaches and dunes, they want to migrate landwards to adapt to coastal climate change. This requires us to accommodate erosion. So coastal management used to be framed as a series of questions about a narrow fringe of the coast, but it's now much more about an intergenerational sustainability and future smart, flexible approach. The world is changing, thinking is changing because our climate and coasts are changing. So we have developed a series of adaptation and resilience recommendations for 7 locations around Scotland. The options include both conventional coastal risk management as well as associated land management measures. But one key difference that I'd like you to take home with you today is that managing erosion and flood risk are different, because erosion typically leads to land loss, which is often permanent, and permanent at least on development planning and on human life timescales. And so you can see here, you could potentially adapt your buildings to accommodate this floodwater on land, but it's much harder to accommodate this erosion on land and manage it. So it means that measures like land rising to reduce flood risk damages and new housing developments aren't suitable for managing erosion. So we instead need to accommodate erosion. So what we developed was a series of dynamic adaptation pathways for managing these erosion risks. And the accommodate erosion is about making space in current and future plans to accommodate future erosion on land. And it requires strategic development planning decisions taken now to provide that space that we need for future adaptation. And that will minimize societal impact and costs, as you'll see a little bit later on. This is an example of that smart, intergenerational, sustainable, flexible approach. And so you can see that accommodate erosion, we've also called it erosion resist. And so as we take an example from Edinburgh, on the left was the original master plan. The thumbnail in the top left, top right-hand corner of the left-hand slide is illustrating where the development was proposed. You can call it a kind of conventional development, going right to the current coastal edge, not being reflexive of the risks or the dynamic nature of the coast that has been described earlier in the presentation and illustrated around Scotland. And so what the city of Edinburgh has done, which is really transformative, is they've tried to shift from a coastal risk to a combined risk and land management frame, this climate smart decision making. And what they've done is on the right is they've replaced those planned houses with a park, as you'll see in a minute. But it demonstrates a kind of transformational shift that we articulate in these adaptation and resilience plans in Dynamic Coast 2. And so this just gives you a flavor of what it looks like if you move that. These lines, the red is erosion resist, the yellow is accommodate erosion, the blue is the transformative. But what you'll see is that by realigning the development back and turning what was earmarked for houses into the yellow area, a park, you create a resilience buffer. And so this is what our artist's drawing of this looks like. And it really demonstrates these climate smart actions. Choosing not to build 600 houses now, you really reduce future risk. And so choosing to build in places that have long-term resilience will save future costs for managing erosion risk by choosing to accommodate erosion now. If you choose other options, then the cost to maintain hard protection will be high, and the risk of coastal habitat loss and amenity squeeze for society will also be high. And so if you choose accommodate erosion, then your exposure to risks decreases and other benefits ensue. Jim is going to articulate that more as he wraps up the entire presentation.
Thank you, Larissa. Summing up Dynamic Coast 1 and Dynamic Coast 2, what we've delivered, as you've seen by earlier presentations, significant national updates to the scientific change data for Scotland's coast. We've analysed the change processes and the pace of change and projected those into the future. And we've assessed the impact of that change on coastal assets and our communities, so that we are now in a position we have accurate change intelligence that's available to underpin policy formulation and enhance its timely delivery. Of Scotland's current soft coast, about 4,000 kilometres is composed of beaches and dunes. Of that, 11% has accreted since the 1970s, but more worryingly, 12% has eroded since the 1970s, and that's up 38% over the historical period and the doubling of the past erosion rates. And the graph below shows you that those retreat rates are increasing into the future, and yet our accretion rates are decreasing into the future. There's a strong regional bias to those trends. Erosion is higher on the open east coast, where most of our assets seem to be located. £13 billion worth of those assets are protected by natural defences, beaches and dunes. And yet only £5 billion are protected by artificial defences. So our beaches and dunes, our natural defences, are doing a great job at present of protecting our assets. Previewing Dynamic Coast 2, we anticipate, with updated shoreline positions, that our extents and rates of erosion will increase well above those identified in Dynamic Coast 1. By 2100, accretion will be rare on the soft coast. By 2100, erosion will be dominating along much of our soft coast. And to place that into perspective using St Andrews, you can see that Dynamic Coast 1, the green areas, show much accretion. By Dynamic Coast 2, these are the current rates of change. Those green areas have become erosional, and projecting those erosional rates into the future produces worrying trends for the assets at St Andrews and for similar locations elsewhere on the Scottish coast. With Dynamic Coast 2, our change intelligence has also improved. We are now using Sentinel-2 satellite data, which gives us a 5-day update of the water edge position at a ground resolution of 10 metres. The satellite image gives us the water edge at the time of overflight, so we've developed automated water recognition in each image and time-stamped it with the tidal height. That gives us an updatable height map, a pseudo-elevation model for any beach in Scotland. And for a geomorphologist, this is the holy grail. It really is transformational in terms of data gathering, an updatable digital terrain model for any beach in Scotland. And the graph shows that we can slice this with respect to the image and the tidal height to give exact positions of where the water is at any one position or any one time. And that is really useful information in terms of planning, in terms of translating those coastal dynamics into an uncertain future with respect to sea level rise. So what are the key messages from Dynamic Coast? Well, it supports resilience and adaptational planning to better manage our coast in a changing climate. It gives us reliable and up-to-date change intelligence, which is the key, but that's got to be deployed through the planning system to have on-the-ground improvements that are needed. Are those new coastal erosion and erosion-related flooding risks adequately accounted for in our local development plans, I ask? Whilst we may choose to retain and defend our key urban shores, elsewhere we need to safeguard coastal space. That's the key. We need to allow the coast to move inland, to create space to accommodate that erosion. We need to create coastal space to allow existing assets to be moved away from risky sites to increase resilience. We need to guide new development toward risk-free sites, as you can see from the Edinburgh example. So our current approaches need to change. We need to adapt. And this involves a perspective shift away from coast-based and towards land-based policies. Planning decisions now on land will lock us and the coast into a much more constrained future. We need to be sea level wise. If change is expected, we need to have a dynamic, adaptive approach. It's not the strongest or most intelligent who will survive, but those who can best manage our change. We need to step up to that plate.
For more information on the Dynamic Coast project, please visit us at www.dynamiccoast.com or keep in touch with us on Twitter.